I know this looks like a drone body with a lot of wires and components, but give me a few minutes and I will tell you what this is and how I plan to use it to create my future robots and drones based on this project prototype. In my previous projects that can be seen in the videos on my YouTube channel, LotBot Robotics, I used different technologies, both hardware and software, to develop some robots and drones. After a lot of evaluation, I have decided to use specific components to develop additional robots and drones. I will just use the word robot to refer to both in the rest of this video. One of the main features is having a display on the robot to be used to set parameters and display data, especially when you're testing away from a computer. For this prototype setup, I'm using a drone transceiver displaying data that is being sent to 2 receivers. Instead of a drone transmitter and receiver, one could use other types of transceivers, such as these. Come in various frequencies, or Bluetooth. You can use this HC05, or with Wi-Fi, you can use the ESP8266s. They come in different varieties, and they're very plentiful. Also the ESP32s, they come in different forms also, and this one actually has a little display on it. You can also get just a gaming control and use the buttons instead of gimbals, or you could go ahead and use any of these other devices with very inexpensive gimbals that have clickers, and you can use switches to send other kind of data, or you can just use potentiometers also. I have used these components in my other projects instead of drone's transmitter and receiver, but the drone environment was very available from my other projects and easy to use as a platform for this project. However, this prototype should work fine for bipeds, quadrupeds, hexapods, and wheel-type robots. Let me give you an example of how I'm using the display. Data related to the movement of the gimbals is being displayed. Let me just move the gimbals a little. You see, the left column of numbers is the left gimbal. The right column is the right gimbal. The top number is the gimbal going up and down. And then the bottom number on the left, that is the gimbal going left and right. If you notice, the top number is now sitting at 2014, and that's the limit of the top gimbal, and it goes down to 992. However, for the motors that I want to process, or servos, I would prefer having a limit of 1,000 to 2,000. So another switch can use the map function to map the gimbal's limits to the limits that I want. So now the gimbal going up and down, the bottom is now set to 1,000, and the top now goes to 2,000. Another flip of the 3-way switch and sets it to arm. And unfortunately, I had the gimbal on the top, and which kicked off the motors. Now, there's other functions that can be shown on the display by using one of the knobs on the transmitter. So if I turn the knob on the transmitter, my switch was still set. So I have a way of calibrating the gimbals. That sets the limits that you saw going from 1 to 2000 and moves those limits to an SD card, which will be read in when the base project is initiated. So it also will calibrate the ESCs. There's a sequence of events that I will describe in a future video that shows you how you can calibrate the ESCs to control the motors on a drone. Of course, you don't need that step for a robot. And I do have a ESC calibrate test also that allows the motors to spin up and spin down to show you that they are all in sequence. Okay, now there is another knob, and if I initiated that knob, it would show you a system maintenance function, and in this case it allows you to initiate or initialize the gimbals to mid values so that the actual calibrations can be done during the calibration function. Anyway, that shows you how the display in conjunction to some sort of transmitter can work in this project. The logic required to use the data received from the prototype is developed on a computer running the Arduino IDE. I run it on a Mac, I've run it on a PC. You can run it on a Raspberry Pi, and then it's downloaded to this STM32 via the serial USB FTDI connection. The STM32 is called also a blue pill, and the connection from the FTDI is through the RX and TX pins over here to the 2 pins on the STM32. A few things you might want to know about the blue pill. The first thing is, in order to know where the different pins are, like the SPI interface that the SD card adapter uses, or the I2C interface that the display uses. The pins on the blue pill have different specific places where you would want to connect those devices to. And another thing is that even though the STM32 is powered by 5 volts, the pins on this side of the blue pill are 5 volt tolerant, where the pins on the other side are mostly 3.3 volts. And so there is 2 pins over here that I use that are 5 volts tolerant. One of the things that bugs me about the STM32 is when you connect this thing to download a program from the IDE, you have to reset this button, and then you have to take this little jumper and you have to pull it out, and you have to put it over here if you're using this serial connection. There is a ST-Link connection which does it differently, but this is the way I was using it. But this connection, having to use this thing to move this jumper has always bugged me. And it turns out you can buy a, as you can see, I'm having problems just getting it off. But you can buy one of these jumpers that has a little handle on it. It makes it a lot easier to connect. And you can just, anytime you want to change it, you can just pull it off with your fingers. Usually you're testing with the jumper in this position, and you're downloading the sketch after you do a reset in this position. When I am developing the code and downloading it from a Mac, I'm getting enough power to power the electronic components that are on the breadboard, but that's not sufficient for the motors. So when I'm trying to use the motors in addition, the mechanism of simply using the power from the Mac won't work. So in that case, I use a 11-volt battery, and it has a XT60 connector, and I have to connect it directly to the prototype through this connection. The problem is every time I plug it in, the thing kicks off, and you don't have a good way of starting and stopping a test. So what I did is I made this little connector, has a little switch, so that I can plug it in, and it won't start until I hit the switch, and then you can see it does start. So I'm not going to let it go right now, but what the power from the battery goes to this distribution board that is part of this frame. Of course, on a robot, you wouldn't have that capability, but you could put a power distribution board in there, and then in this case, the power is distributed to the ESCs for the motors. But there is also 2 wires coming from the distribution board that goes over here to a 5-volt voltage regulator that connects to the breadboard. When I was using the Mac power, this device connects to the breadboard with these 2 wires right here for power and for ground. This voltage regulator will put out the 5 volts. It's also connected there. So if I'm coming in through the battery, I get the 5 volts on the breadboard. If I'm coming in through the computer during electronic device or software development, I come in through this other device. Well, just a few final things I just want to mention. This, of course, is the SD card adapter, and it has a little spring load, and has a SD card that I use to store the gimbal limits on there at startup. It could be used for archives or for other things. I'm not sure exactly what I'm going to do with it completely in the future. The adapter is connected to the power supply by 5 volts, but the SPI interface comes over to the 3.3 side of the blue pill with these 4 wires, because this is a 3.3 volt device, even though it has the power coming in as 5. The receivers, they all function, for the drone users, would function as 5 volts, and all of the drone wires are coming over to the 5 volt tolerance side, except for these 2, which I had mentioned earlier. There was 2 5 volt pins on this side. Anybody with drones might say, well, why aren't you using the 5 volts off the BEC connected to this ESC? And that's mainly because this is a device that's is used for drones, and robots would be using servos, so you wouldn't really have this 5 volt capability. And I didn't want this to be this prototype just to be connected to drones, even though I'm using this platform. Future videos will discuss detail of each of the components identified in this video, as well as any robots or drones that I build using this LotBot Base Project prototype. However, it could be modified for various projects. If you are interested in this project and where it's going, please subscribe. Also, if you think of any maintenance functions or data that would be helpful to see while testing a robot or drone that is not connected to a development IDE, please let me know. Thank you for watching, and stay healthy and safe.